Any questions for either of us about our presentations so far? And by the way, don't feel bad about asking anything in general. There's a lot of different things that we have opinions on in our own particular companies and our areas of expertise. We'd be happy to answer that. And anybody who's online, I saw that hand. I'll get to you in just a second. Anybody who's online, please post your question and we'll have somebody here to speak for you.
Okay, so you said that you have a lot of opinions on what Google could do differently. So what are those opinions? Like, what could Google start doing differently to get to a better point?
So I think one of the big things is what you incentivize, right? Like time spent as a manager made me think a lot about what incentives am I handing to the people that I'm working with, and how do they respond to that, and what does that produce? So you kind of have to be thinking like one step removed, that level of indirection that he was talking about. And I think Google's mistake was saying like change is good without thinking about whether that change actually makes a positive impact or not. I think one thing that you need to do is you need to say, okay, has this person been and has their projects been a direct benefit to their team, to their group, to the company as a whole? Have they produced something that is new in a useful sense as opposed to just change for the sake of change? I think if you set up people's what they called ladders, their technical requirements at each level of engineer, if you set those up in such a way that the person is rewarded for producing a product that works well for a long time for a lot of users, that reward path is a very good one. So you want to make sure that not only do people have the incentive to make a great thing, but to keep it working, because there was too much of a possibility of saying, okay, I've got this thing working, and now it's somebody else's job to make it keep working. I'm going to go do another new thing. And it's great to have people who want to like try and push technology in a lot of different directions, but not if they build something that when they hand it off, it is completely impossible to maintain. So we need to make sure that there is some incentives in there that are retrospective in some sense, that somebody who is taking over maintainership, if they're doing that, or if the person is continuing their own maintainership, that there's a reflection back of, did you build something that could be maintained, that could be managed by a team? Because you may have noticed that Google has a history of deciding to produce a new product rather than fix the existing one. And that's part of the problem. That's the incentive of like, you get a huge boost to your career by producing this change. Do you get a huge boost to your career by making something that somebody wants to use a decade later? And that's what I'd like to see. Does that answer your question? Cool.
I've seen a lot of these, both Google and Facebook, doing the monolith way. So what was the original thoughts regarding benefits? Why did you choose that path? And was there the benefits that you actually expected from doing it?
Yes. So there is a talk about this that was done back in 2015 about what's called Piper, which was the code name for Google's monolith. It's worth taking a look at it because it's from the perspective of the engineering team that produced Piper, and they talk about why it is still valuable to them over time. It is kind of rainbows and unicorns, as he was saying earlier. They really are going like, all these great things. Yeah, there's a couple of things that might be wrong, but really it's all just amazing stuff. But they do talk in some detail about that. So if you look up on YouTube for a talk that is a 2015 talk on Piper, you'll find a lot of details on that. Now, I don't want to leave you just with like, look somewhere else. So I'll say a couple of things. One is that you know that everybody is using the most recent version of things. You don't have to worry about like, oh, what if we have some percentage of our code base that's using really old versions of stuff? You don't have some random service, because Google, like you think of a few major Google products, there's a couple dozen. But really, there's many services that are inside Google and external to Google that you may not think of. Things like the typing prediction as you're typing ahead when it's contacting the server for that back before they had the AI on the handheld. And you don't want to know, for security reasons, that some of those are old. That's very bad. You also want to be able to say, look, we've decided to make an infrastructural change that is going to affect what everybody has to do. Like, for example, they decided that they were going to change from a key value store for a huge portion of Google's base data to going to something that is queryable by SQL. That's a major change. Like, those are completely different concepts. Although, little hint here, there's a talk later about how having all of your data in one API is a good thing. But if you're going to make that level of change, it's really difficult to do it if you're having to do it piecemeal, partially because of those incentives that I talked about. The idea that if you don't have an incentive to either complete changing everybody else over or failing the project, what you end up with is 25% of the people have converted, 50% are thinking about it, and the remaining 25% are never going to get around to changing, right? And so you can never turn off some of these old services. So those are just a couple of things, but there's a lot more in that talk. Oh, and I should say, by the way, that talk is what allowed me to do my talk, because otherwise I'd be violating my NDA. But they said enough stuff in there that I can actually talk about it. Yeah.
Just to add a little bit.
Sure.
I want to add to the opposite. So I've seen a lot of projects that started with, well, not hundreds of thousands of developers, but still hundreds, that started off with microservices and just chasing the exact same rainbows and unicorns, and they were in a far worse place. I mean, Google got their stuff in production.
Yes.
They did not. So it's a very different, a very expensive way to fail, right? If you want to fail, do it fast, do it obvious. The way you don't want to fail is do it slow, expensive, spending a lot of money, trying to fix your career. I mean, in the end, somebody's head is on the line, right? I've seen some examples of that too. So I would definitely go the monolithic way, then evolve later on. But don't hang on for too long. I'm afraid that's
starting there.
Just add more engineers and problem solved.
So and to key off of what he just said, like it was absolutely something that helped Google to move a lot faster and do a lot more in the early days, especially when it was like, we have a few of our core people who are producing the low-level infrastructure that everybody will use, and all the people on top of it can simultaneously be going like, what is this going to be like? What do I have to think about? It allowed the entire company to move really forward really fast for the first 10, 15 years of its life. After that time period, there's the question of, is it still valuable? Well, so far it has been, but there's actually a reasonable question there. But before that point, in the early days, it was the best by far. Sorry, go ahead.
Yeah. So Allard, you said that you should build a good monolith first, and then move on, and it will be easy to switch. You said. Have you ever seen such a monolith? Is my question. And what does such a monolith look like, and perhaps what does it absolutely not look like?
Yeah. So yes, I've seen some. Actually, there was at a particular conference when I did a talk, there was a gentleman that came up after my talk, and he wanted to thank me. Okay, yeah, I did a presentation. You're welcome. No. I want to thank you for that concept, because they had started a project, and the idea was to have around 100 services, right? I mean, you know how architecture diagrams are created, right? A big piece of paper, the biggest you can find, and then put two next to each other just in case, and then design the whole thing, right? And then the whole noun search starts, right? So all the nouns, like, we have a customer, we have a product, we have a payment, we have this and this and that, and they all become these concepts. And then the lines start, right? Oh, this interacts with that and that, etc. And they decided to actually build a monolith instead of the 100 services. They said, let's put everything in one code base and have everything deployed as one monolithic unit. And they started off, and that did not, well, it worked, but to a certain extent, and they noticed it was too much. And they started extracting some components so that the teams working on a specific part of the process could take some of those components and work with it in a different cadence. Right? And they ended up with 7 microservices. And he said, that's enough. It's just enough to have 7. And that's exactly what I'm trying to get to. It's not about the monolith. It's getting to the smallest amount of components that gets the work done. Because the further you go to the right, the more effort you need to maintain the modularity in your system. And at some point, if you have a small team, especially in companies that are starting off with a new product, and you have this new product team, or startups even, where you don't have the resources at all, try to stick to the left for as long as left as you can get away with. Right? That's where you want to be, as monolithic as you can get away with, and as far as the right as you can afford. Right? That's the balance you need to find. And this is just one example of a story, but I've seen them as well, and it is actually easy to scale. I will demonstrate later on. It is actually really not difficult. What it is difficult is find that modularity, find that the boundary of components. And one hint: starting off with nouns is the wrong thing. Right? It's not the nouns; it's the verbs. You want to focus on that. It's the processes. And you want to find where these cohesive parts are, right? And the only way to do that is putting everything together and finding out what changes for what reason, and then scaling up. I hope that answers the question.
Yes. But I'm thinking like how, if you have a monolith, if all the code is together, you can just call a function. But is that if you do that in the wrong way, is that what breaks the easiness to step, or is it like you have to do events within the monolith to?
Yeah, so that's a good point. So whenever there's code right there, why not just call? I need that function over there, so let me just put in a dependency to that module and call it. Right? Don't do that. Right? That's where you should use that explicit messaging that I talked about. Send a command on the command bus, and because the component is right there, that command is going to be really cheap. It's an in-process invocation, right? Until that component is not right there anymore, then it becomes a network call. But by not making these assumptions, you allow your components to still communicate with each other. But in some cases, they're optimized and they're in the same code base, which means that if you do a rename of a property on that message somewhere, it just renames everything in all. Right? Shift F6 is really cheap if you're not on a billion lines of code. So you can just do that. But as soon as things are distributed, it becomes different. Right? You cannot just rename something anymore. But you still want to build it in that location transparent way. And this is where the Axon framework comes in and helps with that. It's an open source framework that you can use, and you can like it, dislike it, but there's some concepts. And one of them is that all interaction between components is through commands, events, and queries. So never, ever call a method. And then, well, within clearly your own component boundary, obviously, you can. But then multi-module projects help, right? Just prevent dependencies from one project to another. And they're actually quite easy to find, and you can automate those illegal dependencies, right? You can create ARC unit tests to say you're only allowed to depend on the API and not the actual implementation package of certain components.
Very nice, thanks.
Yep. I wanted to ask a question on. So you talked about event sourcing and scale together, or separately, but not together. And it seems, or event sourcing has I guess, a core on the single point truth, like you said. How would you scale that, I guess, in the best way?
Yeah, so event sourcing is something is a decision you make whether to use it or not for every individual component, every individual place where you want to make decisions and emit those decisions. potentially that's a lot of places in your code base. Right? It could be a very few places, but then used a lot. And there's different ways to scale that. So I sort of passed by it very quickly, but there's this word event store, right? And I said, not everything that stores events is an event store. And the thing is that if you use a relational database to act as an event store, it gives you all the functionality that you need, right? It gives you the ability to store events. That's what databases are really good at doing. But you can also retrieve a subsection of those events that are relevant to your decision. Because probably not every decision made in the entire system has an impact on the decision you want to make. So that it doesn't scale that way. But for example, if you want to make a decision whether you want to accept a certain order, you can look at the events of that particular order and say, okay, what stages has that order gone through? And am I allowed to change the state? Am I allowed to confirm the order? No, because it has been rejected, right? Or it has already been confirmed. You see that in its history. You don't, at that point, you don't care about what other orders have been doing and what happened there. So you can choose that consistency boundary as small as possible. And by making it smaller, you don't need to inspect the entire history. And this is where relational databases become less good, is when you scale to a large number of events, they tend to slow down quite a bit. Right? Typically, the B-tree indexes that are used in most relational databases, they don't infinitely scale. Right? There's this O log n access cost of those indexes. So that means that the more data is in there, the slower they get. So while your business wants to go faster, you go slower. That's not a good combination. And that's why there's a category of databases called event stores that are emerging, and they're designed to have an O1 order of magnitude, which means that no matter how many data is there, accessing the information is at the same cost, but it is very restricted in how you can access that information. And that's how you can scale to, let's say, the usage and the number of events. If you want to scale in terms of number of components and complexity of your system, that's really where you want to isolate different parts of the system and say, okay, the order management has one event store and it uses the order as its consistency boundary, and somewhere else we have another consistency boundary, and among each other they're eventually consistent. And we use process managers or sagas to coordinate the activity between the two. And that's where the choreography and orchestration comes in, to make sure that when something happens in one part, eventually something happens there as well, to go with the flow or compensate or whatever needs to be done.
Okay. Before we continue on, we're getting close to our break time. If you have any other questions, remember you can save them for the panel that will be after our next talk.